Welcome to the short video that will take you through setting up your first RA projects based on the eSquared Studio environment. So we'll be using eSquared Studio today. That's an Eclipse IDE along with the Flexible Software Platform FSP. We'll be using a GCC compiler connecting to the EK RA6N3 with the built-in JLink OB debugger. So let's start up eSquared Studio. The first thing we'll be prompted for is a location for the project. We will remember the last project location we used anyway. Once eSquared Studio starts up, we can select create a new C or C++ project. We select Renesas RA, and then the full project generator is launched. We're then prompted for a project name, in this case GPT timer. And I select the appropriate version of FSP. I can select a target board, in this case the EK for the RA6N3, C or C++, and I can see details of the evaluation board and the device that's been selected on the right hand side. I can choose a debugger. The default will be the Sega JLink. And I can choose a tool chain on the left hand side, being the GCC, ARM or the IAR. If I have multiple versions of a particular compiler, then I can select it here as well. I'm next on to a page where I can select the type of project, whether it's a library or an executable, and whether I'm including a real-time operating system. I'll just use the defaults here. And then a project template, either minimal or a blinky project. In this case, I'll choose a minimal project. And now we will generate the project and be launched into the configurator. Once in the configurator, we have a number of tabs we can use to start to have a look at the project. So within the summary tab, we can see the versions of tools we're using. Within the BSP tab, we confirm the device and FSP, but we can also, within the properties view, start to change some settings. For example, I may want to disable the MPU. I'll leave it as it is right now. We can change clocks. We can change pin configurations. For example, I could choose an I2C device. I want to change the configuration. I could look at things like interrupts, I could look at event links, but right now we're going to focus on the Stacks tab, where I want to add in a GPT timer. So I come here and actually search for timers and choose the GPT timer. And now that's added to the project, I can come back down to the properties view and start to make some configuration changes. So under General, I can come and give a name to this particular driver, in this case my timer. I could use the channel of the timer, whether it's PWM or periodic. And I want to generate a 1 second tick. I want it to generate an interrupt for me, so I come down to the interrupt section. I give it the ISR name, my ISR in this case, and I give it an interrupt priority, arbitrarily priority 9 at this time. Having made those changes, I can go back to, for example, the interrupts tab and actually have a look at the NVIC interrupt slots. And we can see that the interrupt timer has actually been enabled in there. And we can now generate the project, and the source codes will then be extracted from the FSP and placed into the project. So within the Project Explorer, any of the folders that actually have a name starting with RA would typically have files that are part of FSP, and are certainly available to you to view and to edit, but we would expect you, to be honest, to be working most of the time within the appropriate source folder where you will add your own project information. So in here we see the HAL entry.c. So if I open this particular file, there's a few changes I want to make in here. So first of all, it's always good to do some error handling when writing this kind of code, so we can pick up the Fsp Error Handler by starting a name and then pressing Control Space will then prompt us. So I can give it a name of at this time. And now I want to open the timer. If I can't remember the exact syntax on that, I can go to the Developer Assistant, open up the particular module I'm interested in, so it'd be my timer, and I can find the GPT Open API call and drag it directly into my source code. This will pick up the fact that I've actually set the error variable and obviously start giving me the option to do some error handling. So it knows about the API call, it knows about the control structure and the configuration structure I need to pass into this API to open the timer. Once I've opened it, I then want to start it, so I can drag the start in there as well. And I should do some proper error handling, but right now I'll just say while error, and then let's just idle in a while one loop. So I'm going to generate a 1 second tick. So I need a variable to update within my interrupt handler. So just define a variable here. And at the end of the project source file, then I really need to start defining my interrupt service routine. Again, I can't remember the name of my ISR, so I can come down to the end of the developer assistance and drag the callback function into my source code. And I can choose the variable I've just defined. By starting typing, control space will prompt me for a list, and then I can increment that variable. But you'll also see that I am passing a parameter into this callback. If I'm not going to use it, if I want to get rid of any kind of warnings in my source code, then I can use the function Fsp parameter not used and tell it the p underscore args is a variable I'm not interested in right now. Having done that, then I can go through and actually build the code. Hopefully there will be 0 error, 0 warnings, as indeed we can see here. So having successfully built the code, let's see if we can debug it. From here we can look at the debug configurations that have been automatically generated as part of the project generator earlier. You shouldn't need to make any changes in here, but you can obviously go through and review this. You can change the debugger, some of the other connection settings and tool settings. But if you're happy with the defaults, you just press debug. We'll launch the debugger, in this case the Sega J-Link, running on the EK RA6N3. Having downloaded, I can run the code, noting that I've already placed in the expressions view the variable that's updated in my interrupt service routine. So we can see that this is now indeed being updated every second. If we stop the code and we can scroll down to that interrupt service routine, and we can set a breakpoint in that routine by double clicking in the gutter, we can run the code and we will stop in that interrupt service routine as expected. So this was a very simple project just to show you how to use the configurators, how to use the developer assistance, and bringing up your first debug solution. I hope you found this video useful, and if you have, please review some of the other videos in this series.